Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice with two-tailed hypothesis testing for linear correlation and explains how to conduct one-tailed hypothesis testing in StatCrunch. Let's get started. So let's go back to the example we've seen in previous mini lectures comparing shoe print length with height. We can use the data set from that previous example to evaluate the claim that shoe print length is linearly correlated with height. And because we're not specifying positive or negative linear correlation, it's just general linear correlation, then we have a two-tailed test. So the first thing we do is we express our claim symbolically. So the claim is that we have linear correlation, which means they could be positively correlated or negatively correlated. So rho is not equal to 0. The population linear correlation coefficient is not equal to 0. The null hypothesis, always a statement of equality. So we write that out, equals 0. And then the alternative hypothesis generally reflects the claim. In this place, that's exactly what's going to happen. So rho is not equal to 0. This is typically going to be the hypothesis that you have when you just have a claim about general linear correlation. So you'll have a mismatch between your claim and your alternative hypothesis, and the not equal sign there in the alternative hypothesis means we have a two-tailed test. To test the claim, okay, we've already evaluated this example for our linear correlation coefficient, so let's use the test statistic. So to calculate the test statistic, we use this little formula right here. We plug in the numbers we get from our example problem. This is the data that we've already evaluated in a previous mini lecture. Punch this out on the calculator and we get 4.503. Notice we get the same value if we look at our output from StatCrunch. Okay, so we evaluate our test by taking this true test statistic and compare it with the critical value. So here's the output from StatCrunch. Notice here's where we get the true test statistic. It comes out to be the same number as we calculated up above. Okay. Now, to get our critical value, we go to our T calculator and we have a 5% significance level. So set 95% is in between the tails. So here's our critical values, 2.306. and negative 2.306. Notice we have 8 degrees of freedom, but our sample size is 10. That's the thing that trips up some students, is that it's n-2 for degrees of freedom and not n-1. So once you have that, you get your critical values out. Now you can compare our test statistic. 4.503 is going to be, somewhere around here. So you're in the right tail of your distribution inside the region of rejection. Therefore, you reject the null hypothesis. The null hypothesis said that there wasn't any correlation. Rejecting that means there is correlation. So you have sufficient evidence to support the claim of linear correlation. Let's take a look, for example, at one-tailed hypothesis testing. So when the claim is that two variables have either it's specified positive linear correlation or negative linear correlation, then you have a one-tailed hypothesis test. So you're going to write your hypotheses in this fashion. If you have a negative linear correlation for your claim, then you're going to have a left-tailed test because, see the less than sign like an arrow pointing to the left. However, you have positive linear correlation, you have a right-tailed test, so your inequality sign here like an arrow pointing to the right. Think of it like a number line. Negative numbers are on the left, so it's a left-tailed test. Positive numbers are on the right, so that makes it a right-tailed test. And then just evaluate the hypothesis test the same as you would for the two-tailed hypothesis test. The same standards for rejection or failing to reject, and you come out the conclusions work the same way. Just remember, you use that critical value with your student T distribution, n-2 degrees of freedom. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.